do-over. Hello, everybody. Tonight is the real 16th of August, and this is the Robotics Group Builders Night Online, virtual, and we're going to go around the table and share our robotic exploits or not, ask questions. There might be a few people who haven't been on lately, so just a quick update on the calendar. We have a hybrid event coming up on the 27th, which I think I'm now delinquent on for reserving the makerspace. I better get on that. So we're going to have Doug D present to Seattle Robotics Society Robothon.
Interjection?
Yes, sir.
At 3 p.m. Pacific, it's 2 p.m. Pacific. Oh, wait. 12 Pacific to our time. Central.
Yeah.
12 Pacific, 2 p.m. Central.
Okay. You guys, to 5, right?
No. The 5 should be a 12. Wait, now you... the first one you have 2 p.m. Central. That is okay at 12 p.m. Pacific. And that makes it 2 p.m. Central. 2 hours difference.
Yeah, so 12 Pacific is 2 Central.
Right. You had 3 Central.
2 hours behind, yeah.
Yeah. Yeah, but then it's a 3-hour window, right?
Oh, I see what you're saying.
Yeah. Yeah. We
Oh,
can
I
flip
see.
those
Central
back and
to
forth
Central.
the whole time, but I think they're at the same time.
They're
See,
saying
if we all
3 to
lived in
4
Zulu,
hours.
it'd be so much easier. Okay. So let's see. Maybe I can bollocks that reservation up during this meeting tonight. But
Okay.
And then Robo Columbus is tentatively, or now it's fixed, I guess, second Saturday in November, the 12th of November. And are there any other items to update on the housekeeping slide?
One of the things is, remember I said I was going to be bringing some stuff that was donated to that meeting on the 27th, but I was thinking about if anybody else wants to do a swap, that might be a good idea on the 27th. So, if you got a pile of stuff that you want to get rid of, that might be a good time to give other people a shot at it. And there's the Goodwill free bench that you can just dump it at DMS if afterwards if nobody wants it. So just
You don't have to carry it back home.
right, exactly.
Sounds good. All right. Tonight we have lined up roughly in this order, more or less. Michael, then Pat, then Doug D, then John G, and then Doug P. So I'll just put that in the chat, and then we can go. There's the chat. I can stop sharing. We're actually recording with audio, so it's not screwed up like the other time. So there we go. So Michael,
okay.
Earth, you're not in your Skylab.
No, I'm here. I'm here with you guys tonight. So
Excellent.
Anyway, I'm planning on making another. Some of y'all seen it. I made a claw machine. I wouldn't mind presenting that just a moment because I did it at a carnival, Halloween carnival, a couple of years ago. I want to show that just a little bit of that. Is that okay?
Yeah.
I have to present because I've never seen. Y'all seen it, but y'all haven't seen it in action. So I want to do that. Won't be but a second. Let's see. I present. I guess entire screen, right?
Yep. You actually have to click in the picture of your screen.
But I've got some kind of deal here. Oh. Oh, I get it. Okay, there we go. Now, and I'm going to actually do a little YouTube. Y'all see the YouTube?
Yep.
Yep.
All right, this is a Halloween carnival at my church. So, oops, we didn't want to do that. I want to go full screen, I guess. And this is just a little snippet of it. These are people in line. There it is right there. That's my wife there with the mask.
Michael, my screen is frozen. Is that just me?
Yeah.
No, I think everybody.
Yep.
It might be easier to share the YouTube link on this one. There's a way to get it to a certain time.
I turned the sound off. All right.
You probably have lousy bandwidth like me.
Did y'all see any of that?
You could try the stand. Well, I just saw the machine. It looks,
Okay, well, never mind. The video didn't go through, huh? Okay. Never mind. I just thought I'd show that off a little bit. But that's not why I'm really running.
Well,
I'm going to build a second one. It's going to be a... Huh?
You can provide the YouTube link and have Carl play it. He could probably play it. Just post
I
the
didn't
link-
understand.
Post the YouTube link in chat.
Okay, I'll do that. But it's only the last few minutes. You don't want to watch the whole thing. So, let me get the link here. Copy. I guess the 23 mark. I'll put it in here. There, and it's the 23 mark. Is where you want to. The rest of it's just kind of an instructional video I did about it years ago. Anyway, I just wanted to show it. Anyway, I'm going to make another one, but I want to make it a robot arm. But I didn't want to. I want the arm to. I don't want the claw or the grabber to go down. I want it to be on a string like most claw machines. But I want the arm to go back and forth and swing around like a crane, right? But when they push the grab button, it'll drop on the string. So my point is, what I'm telling you this, I want to keep that arm at the same height. No matter how much I go in and out on the arm, it's got to stay at the same height. Okay, so I want to use servos on this arm. So you just picture a regular arm. So here I went to go research servos, and I'm not nearly as savvy with this code as most of you guys on here. So I start researching this code, and most of the stuff is on servos. I mean, I guess if I search long enough, are they like to use potentiometers like that guy right there, and all that is two potentiometers, X and Y, so that when you activate the stick and you let go, the servo goes back to the starting point. Well, I don't want to do that. I want to take my joystick, and when I push it and I let go, I want the servo to stay right where it's at and then pick up where I left off. Because if I want to go back the other direction and let go, I want the servo to stay there. So I started researching. I couldn't really find anything. So my point is, I had a big, I guess what do you call it, a milestone in my coding this week. So for me, what I did was I couldn't find anything. So I've got one of these books. Y'all have seen those, right? This book is old, and I'll tell you what, this book doesn't even, it's so old, it doesn't even talk about internal pull-up resistors in the Arduino. That's how old this book is. Well, they use all external. Anyway, I use this book and some other stuff, And what I ended up doing was researching while loops using that they use, just the LED. And so I started piddling around with while loops and swap and messing around with servo, and I actually got it running to where the servo will stay right where it's at when I let loose of the joystick. So it's just a momentary switch. So I want to demonstrate this. Go ahead.
They make
I take-
joysticks
I take
that
it
do
from your
that.
I take it from your explanation that you consider yourself a novice programmer.
I'm not even. I'm just a hobbyist. Yeah.
Well, a novice hobbyist programmer.
Yeah.
So you-
Yeah.
you
That's
just
what
got learning.
I'm saying. I'm at the beginning, but for me, it was a big step.
Okay.
I'm just
that's-
want to show you guys. And
that's-
now the joystick that's on that video that I'm using is on the video is just a on-off switches. X and Y, plus and minus. They're just on off, and they're used in like arcade machines. I bought it from an arcade thing. So I want to demonstrate how this works for you now. I don't have the switch, but I do have push button, and I just want to show you all this tonight. For me, I've got two, and of course because these servos in the arm are going to be going two different speeds to keep the same height. I've actually accomplished how to do that too. So I'm going to go one direction, and this is one servo, and there's another one, and I'm going to push one direction. One's faster than the other, and when I let off, it actually stops and doesn't move. So when I want to go back the other way, it does the same thing. So I accomplished something real big for me. So that the servo I just used a counter for a while loop with a counter in there that it just leaves the position in when I let off the button. It uses a brake in there in the code. Now I also wanted to point out that these technically aren't wheels, but this is actually turning. So I was wanting a gold star for this today. That's okay with you guys.
Well, I don't know. No.
Gold star. I already
How
put
much
it in
money
chat.
you
It's a
got?
done deal.
All right. So anyway, next time I'm working on the 3D modeling to make this arm, and it's probably going to be another year or something before I mess with it. But anyway, that's all I got to show you.
Do you want me to try and stream that YouTube from my computer, see if it goes?
Yeah, give it a shot. Now start at the 23 mark on the time.
I've got it, 23:19.
Michael, they make joysticks that
Yeah,
don't return like this one. If you can see that, I can push it and it stays
Yeah,
where it is.
yeah. Always
And
have to
you can
spring
probably
load
take
it.
out the springs out of that little teeny joystick, but
Yeah,
you may not be able to put them back if you do.
I wasn't even gonna. I'm gonna use a real joystick that you'd buy, just like the one that's in my video there.
Yeah. Yeah, like
You can get them.
the ones that are for throttle, like that's the
Oh, yeah.
throttle joystick. You just set it and leave it there, but all the other surfaces, like they return back to the center position.
Can you
And
make
Is
that
that
real?
Are those potentiometers?
Yes,
Okay.
both of these return back to zero. On I have two of them, but on a typical remote control, you have one set for a throttle, and it's kind of like a garden tractor. You set it and you leave it there, kind of thing.
Yeah, I was noticing in the video how the claw swings. Would you like to leave it swinging like that to increase the challenge, or you want to actually design something in to stabilize that?
I already stabilized. Say that again.
I was wondering if you have any desire to keep the claw from swinging, or you just go ahead and leave it like that because it makes it a little bit harder.
When I do it with the robot arm, the claw is going to be all the way up on the arm. So when it's moving, so when the arm's moving, it won't be swinging. They'll stop the arm and push the drop button, and it'll just drop. So y'all won't have that swing. I never even thought about that, but actually that's a pretty good challenge. But I designed that. I don't know if you noticed that. I designed that claw machine to win, so that the kids could win a thing and move to the next booth. So anyway, that's my wife there in the funny hair. She's the operator.
Michael, it occurs to me you don't want to control the position with the joystick. You want to control the speed of the claw. So if you push it over more, it goes faster. And then when it's centered, it stops. Is that correct?
No, what I wanted to do is just when they push, well, I can't see because we close it. When they just, this it won't be an analog, but when I push it, the claw goes in and out, in and out. And then it's going to swing like you would on a regular, crane. It would swing on, it'll pivot. It'll have a pivot point and then it'll go in and out. But I just wanted it to go in and out, but to stay at the same height. Because, you start moving these joints on the arm, and the height of this is going to change if you got more than one joint. So
yeah, so you have to do some math or something.
I actually have the code, and I think I'm going to do it because I've got one servo going faster than the other. Because when I do the code on it, when I wrote the code on it, I have one. I can adjust the speed of how these servos, how much they index by indexing the angle at one time.
Mm-hmm.
So,
Michael, I have a question. If I understand what you're describing with my own arm here, I have two joints driven by servos. One's here and one's here. So it'd be like shoulder and elbow. Okay.
But it'll be like, it's hard to explain with the arm.
The shoulder joint can only rotate this way. It can't go up and down, right?
Right.
And the elbow joint can only rotate this way. It can't go up and down. So I don't see what the concern about going up and down is. Neither one of the joints can go up and down.
Well, I just have to kind of maybe show you next week what I'm kind of maybe y'all don't understand what I'm getting at. But if I'm using having it move two joints at a time like this. If I'm just moving one joint, this is going to go up and down like that. So I have to move this joint and this joint.
But now your shoulder joint is moving in two axes.
Yeah, I'm going to have two joints moving and then pivoting at the same time. It's going to swing. Just picture the robot arm doing 180 degrees in the back of one of these little, claw machine, and it's going to be able to pivot 180, swing around. It's going to be able to swing on a pivot and go in and out like this.
Okay, so this joint here can go both up and down and back and forth. Is that what you're describing?
No, it's going to be on like there's going to be a base. Like, see this servo here? It's going to have an arm mounted to it, right? Like it can do this. That's the shoulder you're talking about. But this base is also going to pivot like this. 180 around so it can go up. There's going to be a servo here, and then a servo here that has yet another arm. Like you've seen those robots on the internet, those robot arms you can buy. It's going to be like that. It's going to be hard. Are you following me? You're not following me. This base.
To think about it this way, it's like an inverted turntable with a pendulum.
This is going to be on a turntable. It's going to go around the whole. It'll pivot around the whole cage,
Box. Yeah.
the whole box. And that way they can go around here and pick, they can look at an item and swing this way and then go in and out and go, okay, I want that item. And then push the drop button and the claw will drop right there. So, I mean, I'll show you, I'll probably have a little prototype of this built by next week. And y'all will get an idea what I'm doing. I know it's probably, I don't know, it's just something to do and I'm having fun. So,
Yeah, that's what counts.
yeah. So I don't know if you, I don't know. But my point is,
What is this? What is this fun of which you speak?
I don't know, it started last year. It started last year when I retired. That's when it started.
That's useful wisdom.
I've
Oh,
found that most big projects are simply a balance between frustration and fun.
Yeah, well, I was frustrated with this code because I'm like, I'm tired. I've done a little bit of stuff. Like John, you was asking what kind of programmer am I? I'm just I'm usually a copy and paste kind of guy. And I was telling y'all earlier, a few days ago, especially when we did the last competition, that I'm just tired of copying code and piddling with it long enough to get it to work, and then kind of half understand what it's doing, and then go up to the makerspace and turn the switch on. So,
Well, I'll tell you this, even as a retired software engineer with 34 years of experience, I still cut and paste because it's convenient.
I understand that. But if you want a servo to stop and go, I at least need to understand that. So I did have a basic revelation, I guess. I don't know, a milestone in my life as far as is like understanding how I can manipulate that while loop to do what I want.
Michael, as you move up in your skill, what happens is that you understand more and more detail what the software is doing, and you're able to control it. And so it gets more and more complicated, and you end up right back where you are right now, which is that you work with these huge systems that you just barely understand.
Yeah, like John was saying. And I understand that, but
and then when you really graduate, you sign up for the new Microsoft or GitHub Copilot, where you just type in what you want and it gives you the code to copy paste. Because I guess you get too practiced and good at it, just too lazy to do it by hand. Why do that when you can copy somebody else's library?
Well, there's a lot of people out there that have done a lot of hard work on all these libraries and little demonstrations on everywhere all over the web, and why not make use of their effort?
Oh, I understand, and I get that, and but to have the ability for me not to understand everything, but at least to know how to take somebody else's library and have it make it functional for me, and put it to use to what I want it to do. And I know there's always going to be that stuff I don't understand. It's like
my first PID control algorithm was copy and paste the code, and then dig into it and try to understand what it's really doing.
That's going to be my next project. Is I'm going to try to I'm going to actually try to do that. Try to write my own code about getting a robot to drive in a straight line, and have me understand how it's doing that, because the code I used the other day at the competition, and it worked really good. I got off of SmartFun, and I manipulated it enough where it worked with my wheels and my motors, and that was cool. And but there was a lot going on in that code. I didn't understand what was going on. I mean, on the surface. Oh, all right. That's all I got.
Nicely done. Gold star.
Thank you.
Looks good. I think next in queue we had Pat and then Doug D.
Hey, everybody. I'll be short. Last week, I was talking with Paul and Kareem about trying to track a robot, the path using my GPS captured data. And I just want to present what I was able to achieve. It was Kareem that put me onto a KML file, I believe it was. And select my screen and go there. Can everybody see that?
Mm-hmm.
So here's my house. And I took off. Can you see my mouse?
Mm-hmm.
From approximately here is where I took off from. So I am down, I would say about 20 feet from where I was. I went out and then followed the edge of the park, crossed at the end, and came back down the side. And then back across the park and in on my side of the fence into my back steps here. So I'm about 20 to 30 feet too far south and about 10 feet to the east on my whole path, roughly. But overall, like, in the scheme of things, I think I'm happy enough that I can get near a target with GPS.
That's pretty
Pat,
awesome.
Where on that map, where are you sitting right now?
Where I am sitting, right, I have, right here, I have a back porch in the house. I am sitting, I can't put a pin.
Don't tell him, he's targeting you.
Yeah, call it the drone strike.
Send the missile right where my mouse is.
Okay, so you have a door open next to you?
I have my patio door open next to me.
And which way is that from where you're sitting? Which direction?
The patio door is looking out this way. So it's looking west.
So David, you're going to send that drone right through his door, huh?
just like they did in Ukraine.
Well, that's fantastic. How long did it take to drive around?
I didn't drive. I walked. So.
Oh, this was a walk. This was a okay.
So all the points are shifted about 20 feet, you said?
Yeah, it looks like about 20 or 30 feet south and about 10 feet east.
It seems pretty large.
See, a large shift? Yeah, I don't know why it's so
Do you
far
know
away.
how many satellites you had?
I had consistently, it looked like 11 satellites I was connected to. Which surprised me that I'm out so much.
Explain to me what is this? Your GPS tracking that you walk?
Yeah, this is my GPS tracking. So I walked with my laptop and my GPS.
Okay.
The same one
What
I
are
put
those-
on and followed this course all the way
What are
around.
those points? To those points is that where you stopped at? Those dividing looking lines?
I don't know what that is. So if you can see at the north end, I'm missing points along the top.
Oh.
I don't know if I lost contact with the satellite there. And then every once in a while, it seems like it's correcting itself. You can see what the points are
Yeah,
doing.
there's a gap. Oh, yeah.
But here, there seems to be a gap going across. So I think it's just grab the next point and start from there again.
Oh, so the yellow line on the top indicates that you had points, but lack of it means you didn't.
Yeah,
right?
that's what I believe. So I've got the points and everything is good. And it's hard to see at angles at times. But I've got points on where the yellow lines are at the top. Looks like it's hunting for a position at these points. And
Are you walking at a constant speed or are you stopping at where you can get the data points?
I'm walking at a fairly constant speed. In the corners, I've stopped and turned. But then, like along the straight paths, I'm a continuous walk.
Is the antenna above your body, Pat?
No, the antenna was laptop height in front of me. So as I'm holding it chest high.
You have to get a helmet. On top
A
of the
little
helmet.
mask on my helmet.
Yeah, I found when if I'm
so-
looking at, or if I get too close to the robot platform, it's not as accurate. So I don't know if don't know, my eyeglass frames or belt buckle or water in my body or something. Seems like my readings aren't as good if I get too close to my robot.
Okay.
Don't
But it's just
know
a-
if there's
it's-
any relationship there, but
Yeah, so my next step, I think, is, I don't know, magnetic fields. Do you have a steel plate?
in my head, no. Sorry.
I think
No.
my next step is to, my next step
A lot
is
of
to
silver filling.
go from one waypoint to another. So I'm just going to do the same thing, start at one end of the field and see if I can calculate a distance and direction and head off in that direction towards the point.
What is it? I think live oak leaves are like a quarter wavelength. So they make like a nice little antenna. So you don't want to go under a live oak tree in Texas, But apparently it does affect.
We don't have that problem here.
No. Yeah.
We have pine needles and spruce needles, which are way shorter.
Yeah.
So we're probably into the microwave or shorter.
Oh, the range, yeah.
So, but that was my experiment, and I think it was Kareem that told me to use a KLM file and put it into Google Earth, and that worked well. I was just able to upload the file and put it in there. At least I get an idea of what's happening. So
Those are real handy.
yeah,
It's nice.
So,
Real
so the
nice.
next one, I'm going to try to see how I do between a couple waypoints and from one point to another, and see how it goes with the GPS as the lead.
So what did you put the coordinates on? Was it like an SD drive or something, or?
Well, I'm
SD
using
card?
a Raspberry Pi, so I'm just saving it to
Oh.
my hard drive on a Raspberry Drive, the SSD.
Okay.
So that's the one advantage with Raspberry Pis. It's really easy to get data in and out, and so even then I'm like today I just have my laptop. So when I go out there with the robot, I'll probably set up a hotspot or like an access point and basically go without any internet on it, but being able to connect the laptop to the robot and still capture and see what's going on while I walk. So you just get a battery powered router as an access point to my.
Pat, I wonder if those offsets could be a latency issue. That is, between where the point is sampled and recorded or something like that.
Well, I thought of that, but I'm already from the first point. I'm still quite a bit south of where I am in reality. So if it was latency, I could see it changing as I started to walk.
You might just take the GPS out there and set it in one spot, leave it there for an hour, and see how accurate its location is.
I did that with the software that came with it and sat it out, and I was typically anywhere from 2.5 meters or so in general away, which is 8 to 10 feet is what it thought in diameter from my central point, or sorry, radius, sorry, from my central point. So it's like a 5 meter span, which is 15, 16 feet.
But was it wandering over that hour?
Oh yeah, I wandered all over the place.
That sounds different from this consistent offset that you're seeing.
Yeah, and I don't understand why I've got that constant offset that seems to be, you can see it's following me as I walked around the park, and it's it's pretty consistent. It's just everything is really offset. Like I say, about 30 feet south. And
one thing that struck me when you described the display algorithm was that I think it plots the line. I think you said it plots the lines 10 feet or 100 feet above the ground. And I just wondered if there's a parallax kind of issue.
Yeah, the one thing that did surprise me is the difference in altitude I was getting on the GPS. So on that plot, I've set the altitude at 230 meters, I think, which is quite high. Not above the ground, just at above sea level. If I set it closer to reality, if I use the values that I get, it actually, when I'm trying to display it on Google Earth, it dips below the Earth, and then I can't see the line at all.
Goes subterranean, huh?
Yeah, exactly. Goes subterranean, and it's quite interesting to see how far of a difference there is, because that's relatively flat. I don't think there's 2 feet difference anywhere in the park from one end to the other. And I'm seeing
there is a setting in KML files called clamp to ground, and you can apply that attribute to a group of data points, and it will force it on render to stay at ground level.
Okay, I'll take a look at that, because it'll be easier to visualize it.
Yeah.
That's good. That's all I had. I just wanted to give an update on how I had made out and what it looked like.
Very nice.
Thank you.
Next step, integration with the platform.
Next step, integration, with the outdoor bot, the one on the plant stand.
So you're going to move the GPS to the one by the plant stand instead of adding an exoskeleton to your own legs. Okay, that's
exactly
fine. That's okay. One kind of integration or another.
Well, there's a 26-pound limit for the Robo Columbus, so that's a far cry from the 200 plus.
Fair enough.
Pat, it's been pleasant watching it get dark outside your house there.
It happens every night.
But normally we don't get to see it in Texas.
Same here.
Yeah, when I was in out west, my son's in I don't know, middle Alberta. It was 11 o'clock at night, and it was still bright enough that you could read a newspaper easily. The sun set probably at 11:30 at night, and it was up shortly after 3 a.m.
Yeah, the first time I experienced that was in Finland. I don't think I pronounced the town right. Rovaniemi. It's inside of the Arctic Circle. Sun kind of dips down a little bit, but then goes right back up in the summertime. So you come out at 2 o'clock in the morning and it's bright sun.
Huh.
Very strange.
Been there and done that. There was one drunk night when I wasn't sure if it was AM or PM when I woke up.
Mm-hmm.
Enough said.
That's fun. All right. I think, there's a segue. So, Doug, I don't know if you're awake or asleep now, but I think you're next in queue. Doug D,
Okay.
and then we had John.
A couple of real short things. You can probably see behind me here. I've got Roby sitting there. He's ready for the demonstration on the 27th. He's got his functional abilities. I can drive him and do all that kind of stuff. I think I showed it last meeting. And so come down to the makerspace on the 27th and you get to see it live and in person. And then the other thing, I'm going to share my screen because I found something interesting today. This robot here called the Luna Zebro. The college is building over in Netherlands or someplace over there. But what I thought was interesting was the shape of these legs here. It's almost like it's going to be a lunar rover, and they actually have a video. I'm going to see if it plays.
Doug, those are called WAGs.
Oh, cool.
I think they were invented.
I'm hoping this is going audio ways. I'm going to kind of skip through it because I want to get to the
This
robot.
concept was further expanded. Group was are designed to go.
Here we
We
go.
are building the world's smallest and lightest new rover yet.
So the thing about the size of a piece
The
of
Zebra Rover has the footprint of
paper,
an
11
A4
by
sheet and
9.
weighs about 2.5 kilograms. Therefore, one of the biggest challenges within the project is miniaturization. This pushes our engineers to be creative in their engineering. A good example of this are the cameras on board the Zebra, which were designed in-house and have a mass of less than 2 grams each.
I'm going to put that in the chat in a minute.
The most unique feature of the Zebra is its locomotion, of course, which is done using C-shaped legs based on the Rex project from the University of Pennsylvania. This enables the rover to traverse difficult terrain.
University of Pennsylvania.
And our in-house software detects which obstacles the rover must avoid and which it can climb over.
The first moon mission is going to be a technology demonstration tested.
This time, the
If I
rover
can
will
get it.
communicate direct, which is a radiation sensor that will measure the levels of radiation on the surface
There
of
it
the
is,
moon.
walking along a
Overall, the
lunar-like
first mission
surface.
for Zebra will be one
Sure
moon
that's
day, with
Photoshop.
14 Earth days long. And during this time, the rover will communicate directly with our ground station network.
So enough of that. Let me stop here. I don't want to bore people with my videos, but I'm going to put that in the chat. Oops, that's not chat. Chat.
I'm not sure I see the advantage of those over wheels.
Mm.
You know, it looked to me like they didn't get stuck or had a little bit of
Well, it's
momentum because of the spinning thing. I don't know.
It's just part of a wheel, right?
Yeah, it's a
Yeah.
wheel, but it seems to have a different way of not getting stuck or having better thrust. I don't know.
I think
mean,
it's about
check
the
with these guys.
size to just fit it in and make it light. I think that that was
It
one
did
of
look like
the.
it's very light.
Mhm.
But let's say this is a wall here, so we're a step. Let me get a step. Oh, here's a step. Okay, got to go up the step. If I have a wheel and I'm running up against this, I've got to push up over it. But if I got something that's going all around and coming on top of it and then pushing, I get some lift to it. Am I making sense? So that might be, otherwise it may overcome steps easier by swirling around and attacking the step from a different angle, as opposed to a wheel which is trying to pull itself over.
So the wheel is constant diameter, but the wag is actually kind of a spiral, so that
Yeah.
the edge of it that's attacking is actually smaller than the edge that's going to end up on the.
Yeah.
Is that what you're describing?
No, it when it's turning. Okay, so when so a wheel, it hits the step, it has to come up over it like this. That's its attack angle. All right. The other one is more like, okay, it comes over and it hits it from the top.
But in order to do the movement you just did, it's because it's kind of a spiral. That is the point that it's
I didn't see that much on it. Yeah, I think you're right.
Further away.
It does look like a spiral.
So it can kind of climb up the.
Yeah, that's what I would think the advantage would be.
That makes sense.
Yeah, if you watch the entire video, you see it traversing a couple of different types of surfaces. It was really kind of interesting. I didn't want to bore you with the whole 8 minutes. I put it in chat so people could see it on their own.
There might be also, I don't know about timing, but you might be able to time the wheels differently to get.
They do seem to do that. Just watching the video, it seemed like sometimes all the wheels are going at the same time, and sometimes they're going at different times. I expect they're doing some sort of logic to plan that.
Well, it seems like you'd have to do that in order to have at least 3 points of contact all the time.
Yeah. So next
person. That one, the robot only had 4 wheels, or did it have 6?
They showed both configurations in the video. It's like it started with 4, and then later on it had 6. And then
okay.
I think they pieced the video together from other shots.
Yeah, with 4, you might have to always go the same. I don't know. Interesting.
Interesting. I noticed also when it had its 6-wheeled configuration, the middle wheels were wider stance than the forward and the back wheels to help prevent clogging or.
I could see where it could do something like this. Okay, so it's 4 wheels. So the first 2 wheels are going here. Now, if you move both of them over to tack from the top, you know, there'll be this period where you'd have to dip down. You know, you'd have to bow in front of the obstacle. It might be where you could leave one like this and then just take one wheel and bring it around to the top. And who knows? Anyway.
I wondered how adding the rocket bogie structure would affect those wheels too. Because that kind of rocks it over the thing and the bottom one catches up. There's lots of experimentation to do. They say they're going to fly the thing up to the moon next year and see how it handles radiation and temperatures and stuff. And if they get lucky and it works, then they're going to make a swarm of them to kind of run around and see what they'll do. European Space Agency project.
Interesting. I was in 2014 when I was at CMU, we had a project too, Lunar Rover X Prize competition. And at that year, 2014, Red Whittaker also started this rover called Cube Rover. It was a tiny rover. I guess it's a similar concept to this video that you just shared. And the concept was to have a tiny rover, super lightweight. I don't remember the dimensions right now. It's probably 20 centimeters cube or something like that. Everything packed in that. You send it to moon, it unpacks, and you know it has its own autonomy. We were planning to put a lot of autonomy on it compared to the big rover that was planned to go to moon. So the Cube Rover, that's what we called it then. I think now it's called Moon Ranger. That's also scheduled to go to moon sometime next year, I guess.
Yeah.
With Astrobotics, that's a startup in Pittsburgh, spun out of CMU.
Is that
No. What, right?
So
I said, was that Andor? It's Korean.
There's a website that lists the capabilities of the robot that come about through these funny shaped legs that are different than what would be the case if it used wheels. So they say that the use of legs instead of wheels or tracks opens the way for a large number of behaviors. And some of the examples are a sprawled posture inspired from insects that results in passive stabilization of lateral motion, and traverse obstacles as high as 20 centimeters, which is about twice its leg clearance. So, you know, some of those things. Oh, and walk and run upside down and flip itself over to recover nominal body orientation, and leap across ditches up to 30 centimeters wide. So those are sorts of things that apparently, if you control those legs properly and in sequence, you can do different kinds of things than you could do with wheels. It's a really good question, David. And I was like, wow, that's a really wonder.
Well, I have seen those WEG robots jump. There's a way they can coordinate the legs to all move at the same time where they can jump up in the air, which it's hard to see how you do it with wheels. However, having said that, did anybody see the little one-wheel bouncing robot link I posted to that guy could jump up in the air just by spinning up his flywheel and then torquing to it. Leap up onto its wheels.
Yeah. Maybe they want to see what the. Go ahead.
What are you showing us, Kareem?
This is a WEG.
It's the octopus wheel.
But it's
suction cups on.
It's a WEG that's more like a wheel. So these are individual legs, but there's enough of them on there that they don't create a big gap. So in most of the WEGs, there's basically just this, right? There's just one of those, maybe one every, maybe 3 around the wheel or something like that, or sometimes one, like that robot was showing. And they do have the advantage is that when you have a wheel approaching, say, a stair, the rest of the circumference of the wheel is constantly pushing you away from the top crest of that stair, whereas these have a chance to separate a bit, right? And then it's hard to show, but they separate a bit, and they have a chance of like getting caught on the lip of the stair, and it's in a better position to pull itself up.
That's what I thought.
Yep. But the downside of WEGs is they are jumpy as heck, right? They're like bouncing all over the place once you increase your speed. So when they're going slow, it's pretty reasonable, but you just can't go fast with WEGs. So this was some sort of an attempt to go hybrid on that. Basically some blend of the options.
Maybe they want to go over the Israeli crash, site.
Over the what?
Who knows? There was a while back, there was an Israeli team that sent a rocket into the moon and it crashed. I don't know if anybody remembers that or not.
I don't know.
Yeah, I remember.
On purpose?
So
No.
Right, so what?
I'm pretty certain they didn't want to crash.
The first Ranger missions that went to the moon when we were children, they crashed. I mean, that's what they were designed to do. They were trying to hit the moon, which they did.
Yep. So I wonder if these little robots, I think they were hoping to find, water so they could, separate it into hydrogen and oxygen for fuel. I wonder if that's going to be one of their little missions. Seek water out, I think they said there's some in the craters at the poles.
Yeah, there's more at the South Pole.
And some in the shadows, yeah.
Hey, David, how do they spell that? Leg, the funny leg, what's it called?
It's like WHELEG or something.
Okay, wait a
Just
minute.
WHEG.
WHEG. Like a whale's egg.
It's a wheeled leg. And they just shortened it to WEG.
It's not a whale's egg?
Like this? I put something in chat. Is that how they spell it? Maybe I missed.
WHEG.
Say it with a lisp, so it's a WEG.
So it's WHAEG.
EG.
EG.
No.
WHEG.
Like that. I got it.
Like
now.
I
Let's
just
see.
put it in there.
Okay, thanks. Okay, good, great.
Hey guys, quick diversion. So for the 27th, it seems I missed the interactive classroom and the North Lobby. So would there any objections if we aim for the lecture hall?
I wish John was here. I have no problem with the lecture hall, but the question would be, does it have a TV in it?
It has a full-size screen up on front, or at least it used to. I don't know if it's working.
Yeah, I don't know.
Okay, I'm gonna try and book it and see what happens.
Okay, cool.
Get John to check it out or something. Okay, so next in queue we had, or Doug, is that it? Anything else from your?
I'm all done. I surrender my time.
Oh, great. There's a balance of your, all right. So that moves us on to John. John G. And
Okay,
then Doug P.
so let's see. I decided to go ahead and give the, some of you are familiar with my mechatronic eyes and the skull face Halloween project that I built. I decided to give the guys at Advanced Design a try. And you can see this video. This is his more advanced design. It's more compact. And it would fit better into a skull face, the way I see it. So, and if you look here, this is what the model of it looks like. And instead of all 3D printed parts, it still has 6 servos in it, but it uses these tie rods to control the eye motions instead of 3D printed plastic.
Mm-hmm.
So one difference though is that the way that the eyelids move in this design, in the old design the more basic design that I used, the eyelids can be blinked independently. So you can wink or you could blink. But when you move the eyes left to right or up down, they're locked together. You can't go cross-eyed. You can always, you can only go left or right.
No chameleon eyes either, right?
What's that?
I said no chameleon eyes, where they're independent.
Right. So in this more advanced design, the eyelids can blink, but they cannot. They can blink, but they can't wink. They move together. But now you can make the eyes go cross-eyed if you want to, or you can do all sorts of squirrely things. The eyes essentially will move independently on the X and Y axes. So what I've got so far, let's go ahead and stop this share. Yes. Got this much of it so far. Got the eyeballs, and I've got all the 3D printed parts printed. What I have left to do is now I have to hook up the servo horns and connect them to the tie rods, and then power it up, and then calibrate it so that I can see, where do I get the eyes perfectly straightforward, where I get to the point where the eyelids are closed or they're open. So calibrate all those angles and then start playing with it.
John, are you using a servo shield to control those servos?
No, I'm using a Raspberry Pi connected via I2C to this Adafruit 16-channel servo controller.
All right.
You need a set of bushy eyebrows so you can give it the evil eye and stuff.
Oh yeah, I thought about that.
I'm actually
really
thinking
cool if you could add 2 more servos and actually have the eyebrows, would really enhance the expressions.
That'll be fun. I might later on stick those. Try to do something like that on my claw machine, my new claw machine, on the end of the arm. Have some little eyes that do that. That'd be pretty cool.
Well, this guy, he's got a basic mechanism and an advanced mechanism. I'll go ahead and paste the link to the advanced design in chat. If you wanted to look at it, you may want to, if you're doing 3D printing, so you may want to give it a stab yourself, but I will warn you, the advanced design has smaller parts. I think the smallest part in that design was something like a little bit bigger than the size of an eraser. So it's you kind of have to shave it a little bit, depending on the quality of your printer. And the eyelids in particular, you've got 2 thicknesses of eyelids because they're so thin that you probably probably difficult to print with some printers. I printed the thin eyelids and they held up, but they are somewhat fragile. That's all I had.
Nice.
If we ever do a demo again, that'd be great. You know, you could, watch the people walk by and, give them different expressions.
Well, I'm thinking I'm going to use the new design. Will go into another skull face for Halloween.
Will you have that ready this year?
Well, I've got one skull face working. It's debatable as to whether or not I'll be able to complete a second one because there's a lot of tweaking. I've got to figure out how to fit this new design. It's got a completely different fit into a skull face, and that involves quite a bit of tweaking.
John, I just might add that those ball links that you were showing us that are used in that, those are quite commonly used in radio control and helicopters and so forth, especially helicopters. And to really use them, you need one of these, which is a little tool that you can put those on and take them off without damaging them. Actually, these come in different sizes. I don't know if you can see how that works or not. There's a little U surface there and a little cup and a divot there that you pop them apart and put them back together with. Anyway, get these online, but they're ball link pliers.
Yeah, I don't think I'm going to need that.
You can do it by hand. You can push them on and off by hand, but this just makes it a lot easier, and it's easier on the ball links.
I'm not exactly sure what you mean by pushing them on and off. I mean, they're.
Let me demonstrate.
I mean, the ball is already, in there, and all I had to do was to screw it onto to the link. And the last bit will be just to drive an M2 screw. Will just be insert an M2 screw through there to connect it to the servo horn. So none of that's required.
And you see this ball link right here? It hooks this servo to this. I don't know how well you can see it right there. Okay, so to take that ball link off, you do like this. Oh, I can't. Stay on camera.
Need a third arm.
Yeah. Well, I can't get it in there far enough. Anyway, you pop it off and to put it back on. You turn the wrench over and push it that way, and it pops it back on. I guess maybe it's not clear that this plastic loop. I don't know if you can see that. This plastic loop here can pop off of that ball. That's how you take them apart. The ball itself is screwed in, but
that's not the way that they're connected in this design. All it is here is taking an M2 screw through the hole in the ball and screw that into a servo horn. That's the way it's attached. Very simple.
So you're saying that the plastic link that's around the ball does not come off of the ball?
No, it does not.
I think you're wrong. The way you described.
Let me rephrase that.
It doesn't have to come off.
It doesn't have to come off. All I have to do is to take what I have now, put an M2 screw through the hole in the ball and into a servo hat. Boom.
I understand that's when it's already all assembled. But it is possible to pop the plastic link off of the ball, and that's the way you normally do service rather than unscrewing the ball from the servo horn.
Yeah, but I have no need to do that in this design. So maybe someday.
Okay, you have no need of one of these, John. I take it all back.
No, but for my education, that was useful. Thank you, David.
Cool. All right. I think next, Doug P, we have installed. How did it go? Things come together at the last minute? Not the microphone, apparently. Oh.
Yeah, you're on mute.
This is what I've been spending my week on, and it probably should take half a day, but I ran into getting my pipelines all correctly done, and then I ran into some problems with RoboFlow. So anyway, but finally, I think I got it. So this year I decided, I told you earlier that one of the things I wanted to do was use the OD Lite or another equivalent board to do an object recognition program on my Robo Columbus thing instead of just using a blob detector. Now, I might use the blob detector too, but or I might use two object. I don't know where I'm going, but where this was one of the goals was to get an object detection thing. And I know Kareem's already done all of this, but for me, this was a first. So let's see if I can get it to actually do. So I'm going to try and present from my Raspberry Pi while I'm running a model. So we'll see how that goes. Okay. Okay, so far, did it show up as a share? Okay, that's good. So far, so good. Okay. Now, if I get in the right window, I got too many mouse and let's click on that. Exciting, isn't it? Oh, there it goes. Now, I'll move it over here. That's a kind of a big fail. All right, what I did was my models aren't perfect yet. I'm working on that. This is a light colored thing to see if it would pick up something that was colored. This is a roll of tape, which is roughly the same kind. So you can see, now in general, it doesn't pick them up, but it can. And what it's not doing here is if you look up here in this corner, way up here, there is a cone. It's not picking it up.
Well, it did pick it up briefly. I don't know if you were looked away when it did it, but very briefly it picked it up.
Yeah.
Yeah, like right there.
Yeah.
That's weird. If it's in the center, well, maybe the shading is just a little different on the shelf.
I don't know. I haven't got. Let's see if we can get that one. You can see him back there. Well,
oh, it's picking them up now.
And what I really was trying to do is this. Now you say, well, why do you want to tilt that? The reason why I want to tilt that is because I've got an overhead light. And if you look at the leading edge of the cone, you can see that it's very washed out. Okay. So, it is what it is. It's not picking this guy up now. Let me move one of these guys over there.
Doug, I'm totally confused by what you just did. You appeared to have a cone that you were tilting in the air, and then you let go of it, and it just stayed there.
I put it on my GPS mass on my robot.
Ah.
Okay, that's why it's no, David. It's not magic.
It was quite disorienting to me. It looked like you pulled it out.
I can imagine. But I mean, let me put it this way: there's some things that aren't being consistently picked up, and there's some bouncing around on this, and if you so it's not perfect by any means. But this is where I got this week. And now I'm, remember several months ago, I talked about a a data set that was available on the web. Okay, I actually used that, all of his images as my starting database. And I actually managed, now on this, if you look at this, you can see this. Let me move this up. You can actually see this is popping around every 8 milliseconds, 8 to 15, I'd say, okay, or at least 10. You see it popping around? So this model's pretty fast. That's not the issue. The issue, like I say, is getting it more accurate and everything. And so, like I say, at least I've got a starting point. There's another thing that I'm not sure. I'm using RoboFlow to actually run the model, okay, to train the model. And I haven't figured out how, and it downports the blob that's necessary for the Movidius that's built into the OakD Lite. But it's not clear to me yet how to make that blob persist. Otherwise, when I cut this off, I think the blob disappears. So that's the next step I've got to figure out, is how to save the blob onto the Raspberry Pi. And like I say, these are probably all simple things to do, but you know, I'm just kind of feeling my way, burn by burn, trying to get through all of this. So I'm real pleased with this. I was actually even able to get the original model, which he had running on a Raspberry Pi 4, which I didn't expect, but it only runs about once every 3 seconds. So it's not a very fast model. But this one, I've actually tried a couple of models on this, trying to mess around to learn what I can do with it. So anyway, I'm also got to figure out how to build my data set to make it more robust towards the, just make it more robust. So that's what I'm working on.
That's really cool, Doug. What do you think about the fact that it's only picking up one traffic cone in the bottom left when there's
Right
another
here?
cone behind it that's within the frame?
Actually, that's a good question, and I have seen it pick it up. It's like, in the beginning, it wasn't picking up the cone up on the shelf, but now it is. And I don't know what triggers that. I don't know. Well, I mean, I know what it is. It's a confidence level, and if I take this guy out, it picks up that cone, but it also picks up this roll of tape, which is probably not cool, so.
Doug, it did seem like that at the beginning it wasn't seeing that cone, and then when you put a bunch more cones in the field of view, suddenly it saw that one in the background as well.
Yeah, that's a good question. I mean, and I also, so I'm going to start taking them off.
Yep, there it went.
Yeah. Now, and so I'm still got one. So let's pull him off and see what happens to him. And
the two that seemed to affect it were the ones that were directly.
Sometimes I don't know. It's like when I get close to it, it does pick it up. So something about my hand and the model is enough to trigger the model. Okay. So that's obviously.
I think it's not just your hand. I think any object that enters the field of view near the cone. Take the top of a cone and just bring it to the edge of the view, and I'll bet you it'll pick it up.
It looks like it has to be underneath it, because it didn't work. It didn't work for cones that were on the sides of it.
Got a picture of Donald. His hair is pretty orange. So is the skin.
Yeah. Well, like I say, so I was hoping that it would not pick up the tape. And the reason why I didn't want it to pick, I don't know if a good question would be, is it really picking up the tape, or is it picking up the fact that it's
The color.
kind of looks like a cone?
So what does the model do though? I mean, is the model based on shape? Is it based on color or both?
It's based on cones. See, so it's not necessarily picking up the color. All right. So something about this, the shape, is enough to pick it up.
Which
So,
which AI algorithm is it using? Is it YOLO or one of the others?
I'm not sure exactly which model they're using it right now. I'd have to. They do have a model zoo, and you can choose some of them. So, but the one I was working on was whatever their default was, because I really wanted to see if I could get it. My goal this week was to get it on the Oak D Lite. I did not expect this. This is way better than I expected. I mean, this is.
That's very cool, Doug. I mean, it really is.
And so anyway, there's still a lot of questions. I will say this about the RoboFlow people. Their online chat guy is really helpful. A lot of times you get an in chat guy, and he basically tells you to don't bother me, go away, because this is what I'm using is free. All right, and I'm not even supposed to have chat support, and yet he helped me out. So,
without
a lot of first teams. Yes, go ahead.
This is really cool and really impressive, but I just have to quote Rodney Brooks here, and this is without denigrating your accomplishments in any way, because I take my hat off to you for getting AI working on that camera. But Rodney Brooks said, if you look at any scenario where AI is being used successfully, one of two conditions will hold. Either it doesn't matter if it gives the wrong answer, or there's a human in the loop. And if you think about that, it's hard to come up with an example that isn't one of those two things.
Yeah.
For example, your Amazon suggestions are, it doesn't matter if it makes a mistake, or your Amazon movie suggestions, or else there's a human in the loop.
Along those same lines, Doug, you mentioned earlier that you might use both methodologies, and my experience has been that with blob detection, the problem is not that you don't recognize cones, but the fact that you end up recognizing as cones things that aren't cones, like other orange colored things.
Yeah.
And so maybe a two-stage process could be, first the blob detector says, well, that could be a cone, and then the neural net would say, yeah, that looks like a cone to me, or no, that's a flat disc, that's a flat orange frisbee laying on the ground.
Yeah.
That the color is not enough, but it's a good starting place, and then maybe it could be refined, and then also the OD process would know that something else at least thought this might be a cone as its starting point.
Right, and I can see that. My problem with using just the blob detector was that it's so tricky to get the U right when you're out in the field. You know what I mean?
You mean because of the sun and everything?
Well, it's just that it seems like with the Pixie Cam, it'll work, it's working, it's not working. You know what I mean? And I have no idea when that occurs, and I have a problem. I guess what I'm saying is I find it somewhat unreliable. Now, it's a great piece of hardware. I mean, you know, I've used it in 6 cans. I've used it very successfully indoors. And I know you and Scott have used it I don't know, you have an older version, but
Yeah, and I will say
well,
this.
you both of them use very, very successfully.
I will say this, that my observation using that camera, and you're right, I have the SRS cam, which was the predecessor to the Pixie cam, is that outdoors, it works really well on overcast days, but it has challenges with bright direct sunlight. And I say almost jokingly, but I think there's some truth to this, that this was, of course, designed by the people who live in Seattle. And I rest my case. They never knew that it didn't work in direct sunlight because they had never experienced such.
Yeah, that's like when I see, you know, some of the products being sold and they say it works outdoors, and then they say it's got a 50K lux, you know, max. And, you know, okay, this works outdoors, like you say, in an overcast day or, you know, a sky with lots of clouds. But, you know, in a Texas blue sky with middle of
blistering
sun, no way it's going to work. So the question
so high.
Yeah. So the question is, I've got a bunch of these cameras, different types, because I've been collecting them. And I'd like to see, this was, like I say, this is the first time I've got something on an Oak D Lite. Okay. So we'll see how it goes. And then we'll see how the model progresses. You know, how does it get better as I increase the data set and everything? Because like I said, you can either detect cones by the color, or you can detect by the shape, which like on a Haas cascade, or you can detect it as an object. Those are the only 3 ways I think you can detect it currently for hobbyists. There might be other ways, but those are the 3 that I know of. So,
well,
Doug,
Doug,
if
let's
you
start
invert
off
the cone,
with
does
an
it still
idea.
think it's a cone?
I think you can get depth data out of the Oak D Lite concurrently with it running the AI stuff. And with depth data, you could qualify any potential hits based on there being at a reasonable distance above a ground plane.
yeah, it might be possible. Like I say, you notice right now, the way it's set, this script that I'm running, it's not using, this would work with an Oak D. This would probably, you know, one of the things that I haven't tried, if I can get the blob downloaded, it might even work with a webcam and a Movidia stick. You know, I might be able to use the Movidia stick, and if I can get the blob, if I get hold of the blob, then you know, that's the key to the kingdom. So just have to see how that's working. Anyway, this is what you know. I made some progress, and you know, if you guys want to do something similar, you know, I'll tell you what I know, but I'm going to tell you what I can think of things that I would rather have done than tried to do this. But
hey Doug, if you flip a cone upside, you know,
upside down,
say you invert the cone, does it still?
It'll do a side cone. Well, okay, but I don't think it'll do an upside down cone. Yeah, it won't do the upside down, but it'll do the side cone, at least most of the time.
Got that.
Well, that just tells you that it was probably trained on all images of cones that are upright.
Yeah, you have a preprocessor where you can create additional images from your data set where you rotate them 90 degrees clockwise and counterclockwise. That doesn't mean it makes them all, but it does throw a sample into it. So that's one of the preprocessor options you can do. Now, in this particular one, I think it's because, John, they did have some trained images with it sideways. Otherwise, they always show a couple of knocked over cones when they do a picture that has a lot of cones in it. And so
But
when
no,
those,
but no inverted ones.
yeah, they never show an inverted one. So I think, and this is, like I say, I have other versions of this model. Some of them are more sensitive, but they also they might, in some ways, they pick up more false positives too. So I've got to figure out what I'm doing. The next thing I've learned that I'm going to try and apply is what they call null images. And this is where you add a very small amount of images that have no cones in it. And so the model learns what's not a cone. Do you know what I'm trying to say? So you can see how that works. There's a few, like I say, but I started off with the original article that if you go back in the chat records, you can find it. And I actually got that working on a Raspberry Pi 4. And the big trick to that was one of the programs that you need to run that particular model is you need the Python package called Torch, and Torch Vision and Torch. Well, you don't need Torch Audio, but you get it. But so you need Torch. Well, it turns out the only way you can get Torch is to run the 64-bit Raspbian ICO. You can't run the 32-bit Raspbian because Torch isn't ported to 32-bit. So if you go to the 64-bit, then you can literally put his model on the Raspberry Pi, and it works pretty good. It works pretty good, but like I say, it's real slow. It's like 1 frame per 3 seconds. So, but even that, that wouldn't be that horrible. If your GPS said you were close, you could stop and wait 3 seconds and see what happens. So anyway,
Do you have any idea how many images are in your training data?
Yeah, I want to say the original training data was about 250 images. And like I say, I went out this afternoon and put in another 20. And
Yeah, 200, as far as training data goes, 250 is not a lot.
Yeah, that's why you use some of these techniques where they, like I say, you can vary the brightness, for example. You can vary the hue or the saturation, and it creates additional images from your existing data set. So I have run a model using a couple of those. I don't think they're preprocessors, but whatever they're called. And I've used them, and it kicks up the database to about 600 images. But you're right, John. This is, the problem is, I hate to, you say, well, just go out to Google and start popping those down. Well, I started doing that. That was after I took my own pictures. I decided I'd go down to Google and try, just to see about downloading some of theirs. But then I started thinking about it. A lot of these images are copyrighted. And I don't want them to be in a public database. You know what I'm trying to say? I mean, if I were a copyright owner, I'd be pretty tinkled about that. So, I'm going to have to just take the pictures myself.
Luckily, I've been reading up on neural nets, and don't all the images have to be the same size?
No, not exactly the same size, because that's one of the advantages they did. When they first came out, all your images, the first time I dipped my toes in this, all the images had to be exactly the same. Okay? They had to be square, and it had to be the same size. And it had to be something like 56 pixels or 80 pixels. I mean, it was really very specific. But now what they do is you put in images of reasonably the same size, okay? And what they do is they create, you have a couple of options. They cut it down to a certain size, and either that or so they might stretch it, or they might cut it.
Right. So they
or
crop
shrink
it and resample it.
Yeah, but you don't lose your annotation because your annotations are all normalized. So like instead of saying that the box around it starts at pixel 1723 and goes down to 237 by 48, what it does is it says this is 0.01 of the X and point such and so of the Y, and this one is point X of the 0, some normalized version. So when they resize the image, the bounding box gets resized too. And so you don't lose your annotation. And that's so much cooler and so much smarter, that makes actually annotating the pictures very easy to do. I mean, you could sit down and in a couple hours, you could probably do 1,000 images without too much trouble. The problem is collecting the images.
Yeah. Remember when we had this discussion probably a couple of months ago about detecting fences?
Yeah.
And I was going out to the web and trying to find images of chain link fences, and it was tough, finding suitable images. Even though as many images that are floating out on the internet, it's still tough when you pick a particular topic.
Yeah.
Doug, it seemed, remember the article that you posted for us to read a couple of months ago that guy referred to a small data set as having 10,000 images.
Yeah, I don't think you need quite that much, but I hope not, at least, David.
Well, as with anything,
it was your article, wasn't it?
Well, I'm just saying is I'm not sure I want to go that. I wouldn't be surprised if it takes something really large, but like I say, you have to be careful there, because does he mean 10,000 unique images, or does he mean 2,000 images that have been rotated,
right.
flipped?
What he showed was manipulating the images that were there to get more of them.
Yeah. So I don't know if you have to be, have that, but like I say, it's a beginning, it's a start, and who knows, maybe the Oak D light will actually make it into a Robo-Rama here, a Robo Columbus. I mean, be neat. Now, like I say, now I'd like to get some of the, micro, I'd like to get one where I was using the Movidia stick and a webcam to see how that compares in speed. Just because you could do this with an oak. I think they call them oaks. And the oak is the one that's just sort of like the one that Ray has. And then there's the Oak D, which is like an Oak D light, but on steroids. You don't need it. And then an Oak D light. And so anyway, here I'm not using the depth camera at all, but like Paul said, if this works, well, who knows what might, I'd definitely like to try the depth camera to back up. It'd be nice if I could do that and make my ultrasonics, which can be defeated by the wind and the outdoor environment, make it a little bit more robust too. That'd be nice.
I'm a little confused. Does the Oak D light have a Movidia processor in it?
Yeah, it has the Movidia. That's what it has in it. So, and that's why it's so fast. Is because the inference is actually being carried out in the Oak D light. It's not being done on the Raspberry Pi.
Good.
That's why, because if you think about it here, I'm streaming. I know Google Talk probably doesn't take that much, but I'm streaming on that same camera. You're seeing it. I'm not having to point a camera at my screen. It's actually that's my Raspberry Pi presenting. And
So what
it's
are you-
running it.
What are you talking about when you're talking about doing this with a Movidius stick?
Well, okay, you can buy for 70 something bucks, you can buy something called a Neural Compute Stick 2.
Right, I have one. I use
Okay.
that for my face tracking in the Halloween
Right.
skull project.
All right. So, John, I probably have to talk with you because I want to talk about how to get that implemented.
Well, I'll tell you very briefly what I did. I
Yeah.
used OpenCV, which
Yeah.
has some built-in neural net software,
Yeah.
and the NCS2 compute stick. And all you have to do if you use it, you can use there's a face tracking model that you can download.
Mm-hmm.
And all you have to do is to change one line in the code that tells you, okay, where's my processor? And you point it at the MCS2 compute stick, and I get like a 20 times improvement in speed as opposed to just doing it within the OpenCV software.
Right. And that's why I want to try that, because I really want to get this guy running. I had an older one. That's probably why I get him the name. This one's actually called a Neural Compute Stick 2. The old one was called a Movidius Neural Compute Stick, but it's not supported anymore. It's not.
Yeah.
Yeah, that's not supported anymore.
Yeah, I actually returned the first one I bought because it was the older one you talked about, but I had to send it back to Amazon and buy the NCS2.
Yeah, that one you can use an older version of OpenVINO, and you can still use it, but it's like a 7 times. And like you said, I think this one's like 20 times.
Yeah, and I'm using OpenVINO.
Yeah. So that's good. It's good. That's a good point. I got to see but I haven't tackled that specific problem.
Well,
I had the other stick running.
If you want to ping me somehow, we can compare notes
Okay.
and see if I can be of help. But your project may be so different from mine that it might not be useful. We'll give it a try.
Yeah, you never know. Like I say, I'm not detecting the cone up on the top, but it only has to detect one cone at a time if I can get it to do that. Anyway, we'll see how it goes. That's all I think I had, Carl.
Nice, very nice demo.
Yeah.
Very
Carl,
good.
I'm glad it worked.
Carl, I have something I could show.
Excellent. Let's try. So was that a gold star demo? I zoned out for a minute.
I'm going to put a black star down on that one.
Black star demo for Doug. Excellent.
No wheels on the ground.
And
So
Doug, I can contact you via email through the website, right? Is your email available there?
yeah, if you go out to the website, yeah, I'm a member, so it's available.
Okay. Thank you.
Yeah.
Okay, cool. Yeah, so Mr. David, what do you have?
Well, I haven't done any roboting in quite some time, but I have been at work working with our drone, and I just had a couple of things I thought I might share with y'all. Let me share. Am I sharing?
Yep.
Okay. Do you see something there?
Yep. Looks like Lake Louisville.
No, this is actually White Rock Lake.
White Rock Lake. Okay.
And the yellow line is the path of the drone. So basically just flying out a little ways over the lake at a particular altitude and then flying back. And the blue arrows are wind speed and direction as determined by the tilt angle of the drone, which is kind of cool. If you scroll down here, you'll see there's a flight time and an altitude, and then a wind direction and wind speed at 5-second intervals. And so basically, I've been playing with this, and a couple of the guys at work, let's see, do you have a Google Earth there in front of you?
Yep.
Okay. They wanted to know if I could fly a circle. And it turns out that the drone itself has a function built in to circle a GPS waypoint, which it does very accurately. And so the idea was to fly a circle while constantly having a vertical velocity. So you flew a big spiral like this to try to get wind information. What they're doing is they're doing an infrasound studies. And if we check here, let's see. I have to find it. Hang on. One of these. You can see it flies a pretty darn good circle. And I played around with that to see if I could perturb it, and I really couldn't. But the only one I could really get wind information on was this one, which obviously has an enormous amount of wind information, and I'm not convinced that it's all correct. This is actually, I'm flying a spiral, but you can't see it from here. But if you look like down here at the bottom, there are ones where the wind is going in opposite directions, which I don't necessarily believe. So the question became, they're looking at the algorithm for how this was calculated. And this is what sort of got me interested in all this. I poked down through some of these. These are KML files that are generated by the drone itself. And these are my attempts to fly a spiral. And but what I found, I think, is that we actually got better wind information. I flew a whole bunch of different ones by simply flying straight up, just climbing straight up. See if I can find one of those. I thought I had it right here. There's one. Well, okay. By just doing this and trying to fly as best I could at just a constant altitude, they'd like to go up to 400 feet, which is fortunately the limit for my amateur license. So that actually works just fine. So went back. It turns out that the drone does dump all of this log information, and this is what really got me interested. So let me stop getting off topic here and open one of these logs. Read only is fine. And this is actually pretty fascinating. If you look over here on the far left, you have clock ticks, and basically it asks you how often you want to sample the logs. And it suggests 30 hertz, which is what I have it set to here. I tried higher than 30 hertz, and it seems to just replicate the values. So that suggests to me that 30 hertz is the actual cycle time for the drone itself. And just give you a brief overview, it's amazing the information they have here. So you start with a timestamp, and if you jump over, you can see it's column C here says that it's IMU ATTI 0, whatever that means. And you have a longitude and a latitude, air pressure, altitude, a relative height, an absolute height, number of satellites. Then we have, whoops, if I can do this. Then you have roll and pitch and yaw. And you have X and Y and Z acceleration, something called composite acceleration, X, Y, and Z gyros and composite gyros. Well, there's about 50 log entries here, and it's really sophisticated. So there's velocities. I have no idea what a lot of these mean. Here's our magnetometer X, Y, and Z, and a magnetometer mod, which must be a combination thereof, temperature, a yaw, unwrap, tilt, inclination, tilt direction, earth frame, tilt direction body frame. There's a 360 yaw, a magnetic yaw. And I don't know if you guys can read these yourselves, but there's just tons and tons of stuff here. We jump over a little bit. Here's a bunch of IMU calculations, position and position error calculations, gyro and gyro error calculations. Here's distance traveled. Here's your quaternions, everybody's favorite way to express 3D vectors, and a whole bunch more intermediate values that must have something to do with how that's calculated. I get down here now. Here's GPS stuff with your GDOP and your PDOP and your HDOP and all of that kind of GPS stuff. There's a whole bunch of controller things here. Controller tick, controller pitch, controller roll, yaw, throttle, mode, state, motor state, and a whole bunch of motor control values. And over here, there's actually things like, let me see if I can find it. There's the current going to each of the 4 motors. There's a whole bunch of flags for errors that are all set false. Here we go, motor speed, right front, left back, right back, motor temperature for each one, the ppm send for each one, whatever that is. And here we have the current for each one of those motors. You notice it's 0 here before it takes off. And there's also logs, an event log that tells you all this different stuff that's happening. It's really quite a master class in what could be in your log files.
Man, that does everything except count the number of nearby birds.
Well, I think there's a field over here for that.
So is this a $1,000 drone or a $10,000 drone?
This is about a $1,500 drone.
Really?
It's a let's see if I can. I tried to pull up here. It's a Mavic 2 Pro, and all that data is collected during flight and stored on your whatever your mobile device is. We use a mini iPad. It's a pretty slick gadget.
Yeah.
So what they want to do basically is when they go out to run these experiments, they'd like to take the drone along and send it up to 1,000 feet and get air direction and temperature and velocity and all these things that they can then use to constrain their infrasound models, and which actually looks like it's going to be doable. But I think obviously the algorithm is not right yet.
So where is the infrasound source? Is it airplanes or?
Well, there's all kinds of things. That's a huge topic of study right now. Basically, tons of things make infrasound, and they travel thousands of kilometers. So it's useful to, for example, explosions, airplanes, as you say, helicopters, meteorites, large mammals, elephants communicate with infrasound. And
so infrasound would be basically low frequency?
Yeah, think about it, sound waves, but below around 1 hertz and lower. So
essentially pressure waves.
Yeah, and the infrasound seismometers or the infrasound instruments you can think of are sort of high frequency barometers, if you will. And that's all I have.
Man, I'd hate to sink that much money into a drone and then crash it.
Better have a spare.
Well, isn't most of the, I thought it was very well controlled and that you can, it compensates for a little bit of wind and.
Well, that's what they're actually doing here. If you take the thing out and just hover it in front of you, it holds exact. And if you look at the video that it's shooting, it looks rock solid. Mm-hmm. But in point of fact, the drone is doing this to correct with the wind. So they're backing out by starting with these signals. They're backing out what the wind is.
Yeah.
Although, as I said, it looks to me like the algorithm still needs some tweaking. But boy, there's just a shitload of information there. I'm kind of stunned.
My little brother is into drones. He's had several of less expensive models, but he had one that, when you lose radio contact, it uses GPS to try to fly home. Well, it didn't make it home, and he never found it again.
Oh no.
These are pretty cool. You can just fly the thing like an RC airplane, and you can do it with the first person view by just watching the video feed rather than looking at the drone. But you can also set a series of GPS waypoints, and it'll fly, and each one with its own altitude, and it'll fly waypoint to waypoint. You can do that in what they call polyline or arc mode. Polyline meaning fly straight to the waypoint, rotate to the next waypoint, and fly to it. Arc means you actually just calculate like a Bézier curve that flies through those waypoints. You can fly around, as I said, you can give a central waypoint and a distance and an elevation, and it'll fly in circles around that. You can do what's called point of view, which is you can highlight an object, and it will circle that object even if the object moves. So you can have it circle or follow you as you walk around, which is a little creepy.
Hey, David, with your
and if it flies out of range, or if you just turn off the radio, there's 3 different options. One says, go ahead and complete the course that you're on if you lose radio contact. One says, hover in place and wait for further instructions. One says, turn around, come back home. And is Pat still here? Pat, this thing will I can fly it 1,000 feet away, and it'll land within a foot or 2 of where it took off. It's doing all that with GPS. So that should be doable. It's not, using anything fancy. I'm sorry I interrupted somebody.
No, David, I was going to ask you, with your license, your drone license, you said you could go to 400 feet. Is it okay to go down to places like White Rock Lake and run it there? Or I would think that parks would be kind of like, or is that the only place you can run them? I mean, I don't know.
That was a project that was beyond my control. That was set up by somebody else. Where I fly is I go down to the Denton flying field.
Okay, so you have a special field that you fly at. Okay,
yeah, the AMA license I have, I can fly at any designated flying field. And then, when they have airplane clubs have contests out in some farmer's field, those are all qualified. I looked at getting an actual drone, commercial drone license, so I could. It actually doesn't help us that much, because all that means is that now, instead of going out to the flying field and running my tests, I've got to file a flight plan.
Yeah.
Is that the 107 you're talking about? The Part 107?
That sounds right. It's like you can do the whole thing online, and I scanned through it all, but it just is a lot more than what we need. But I am constrained. I can only go 400 feet up, and I'm not supposed to fly it out of sight.
Yeah.
That's what
Can
the
you
rules
see the drone at 1,000 feet?
Can you see the drone at 1,000 feet?
My 6-foot sailplane, you could almost see it, I think, but maybe with
It's
good
pretty
eyes.
tiny, and this little drone does a whole lot of the things that we want our robots to do. You bring up a picture, it shows you a Google Earth map, and you touch points on it for waypoints, and you tell it what you want it to do, and it can maneuver all that stuff. I did a few flights the other day where I never touched the control at all. It took off, it flew through a series of waypoints, and it flew back and landed on its own. And I will say that, having flown radio control all my life, the idea of not watching the aircraft while it's flying goes against every bone in my body. And the idea that I'm going to watch this little screen and see a camera feed is just something that just feels totally wrong about that. But that's how they're designed to do. Up in Colorado last month, I flew a whole lot around the mountains and over waterfalls and stuff, and it was pretty cool. But and each time I do it, my legs shake a little less.
It's only money.
So do you have the virtual reality goggles, you know, that
We do. They bought that with it. I have found them clumsy to use for two reasons. First of all, they did not anticipate anybody using that wore glasses.
oh, ooh.
I've found there's an aftermarket group that'll sell you a little holder, and you have to special order the lenses to go in those holders. But you can't really use it with glasses, which me and all the old farts that I work with, that's kind of the end of that. The other thing is that there's a whole lot of interaction that's done with the mini iPad when you're flying. Only a small amount of the interaction is done with the actual remote control gadget. Most of it's done by touching and pulling faders and wipers and stuff. And so all that stuff's gone, and instead they gave you this sort of touchpad thing on your right temple that you're supposed to use instead, and I found it extremely clumsy to use. So we haven't used that. When I was up in the mountains, it's so bright up there that I couldn't see that mini iPad at all. So I put a towel over my head, you know, like an old photographer, put my hat on top of that to hold the towel, and I could kind of hold it up like this and sort of see it. But it's very, very difficult to, you know, mostly what I saw was the sky behind and the reflection of my head.
Very cool.
They look like a lot of fun.
And you get paid to do it. How bad is that? That's some.
Well, one of the reasons I had to start collecting all this data was because after a while they started wondering why I just had to go out and fly all the time. But the other thing, and Doug, this kind of flows off what you were saying. What the main graduate student who's collecting all this data is actually building neural nets to analyze the stuff. And he's looking for all sorts of things. He'd like to be able to use just the audio to locate and identify and track what the drones are doing. And there's all kinds of stuff they want to accomplish. But to do neural nets, you need tons and tons of data. And so I've been doing my best to produce tons and tons of data.
Do you have to label it too, or do you just get to capture it and throw it over the wall to them?
Well, it's kind of bizarre. The DJI records this voluminous data, including 4K video and with its Hasselblad camera. I mean, it's gorgeous video, and it doesn't. It's the stability of the image. I mean, after all, the drone's wiggling around that, but the image is just rock stable, and so about half of that stuff you can get to, and the rest of it is encrypted, and they won't let you have it. But when you fly, they send a subset of that to your controller, which is in a weird format, also encrypted, but they will let you decrypt that. So you have to download these tools, and the files that the drone creates are called .txt files. Now, everything I've ever known in my whole life, a file called .txt is an ASCII file. That's what .txt means, American Standard for Computer Information Interchange. But these are encrypted binary files. Why they call them .text is just to throw people like me into a panic. But I finally found a guy online who had a Python tool that knows how to read them and turn them into just you know, comma separated value files, which is what I was reading there. But there's an incredible amount
Share
of
that link, David.
Say again?
Can you share a link to that?
To which one? To the weather one or the
decryption?
Okay, just look up datcon.com.
In case there's anybody online who has a Mavic 2 Pro.
I'll put that in the chat.
Yeah, I do.
Okay, well, I can speak to you more specifically. When you go into your phone or your iPad or whatever, and you'll find there's a directory in there under DPI called, is that me causing that weird sound? Called flight records, all one word, capital F, capital R. And that flight records has all those .text files. And then within that folder is another folder called MAC DAT flight records. And that's the one that has the records that have all that information I was just showing, and that can be converted by this DATCon. But yeah, let me find the reel.
So flying robots, all right?
Well, I don't seem to have it on this computer. I'm sorry. But I think if you search DATCON, DATCON as in Nancy.
What's the typical flight time for those things? Is it half hour or?
Oh, I would say more like maybe 15 minutes, and I've got 4 battery packs.
Oh, wow.
Okay, I found DATCON. Here we go. It's datfile.net.
I found the directory. Yeah, I've got a bunch of that.
You have a bunch of .text file and a bunch of the ones you're looking for.
Mine are .dat.
Okay, the ones you're looking for should be DAT with capital DAT.
Yeah.
Okay, those are the ones. And that will give you all this and tons of information. Incredible.
Okay.
Of course, if you don't want to spend that much money, you can always go for one of these. Just for entertaining the cats with.
Much harder to fly though, right?
Muted, David.
I crashed it a lot.
But they're
Probably
so
no
lightweight, they
correction for
survive
anything,
pretty well.
right?
It's amazing.
You're the corrector.
Now look at
I've
the
never
size,
crashed DJI.
look at the size of the motors on these things. I mean, there's my thumb.
Yeah.
That's small.
You're muted, David.
Thank you. Kareem, if you'll just Google on Phantom, PHANTOM space help. That's a website that can take those .text files and convert those to CVS files. You see?
Cool.
Yeah, you need to. Let me see if I can find that link explicitly.
All right. So is anyone else in queue for after this drone chat?
I'm working on the Ackley rule of 3. I made a kind of a fixture to fit on a piece of tubing, and it was just a little too small. You know, I measured it with pair of calipers, and it was just a little too tight. It always seems like it shrinks maybe a millimeter in diameter. So I made the second version, which is a little too big because I wasn't paying attention to my calculations. And so now I'm going for the third one, which should be in the Goldilocks zone, for.
That is my Achilles heel when it comes to modeling and 3D printing, is figuring out the tolerance.
Yeah. Yep. Yeah, this one was just a little too small. I think I wasn't really paying attention. I measured when I put it on the pipe, I had to cut it to get it on, and I measured that distance. It's only like 2 millimeters. So for some reason, instead of, saying, okay, that's the change in circumference, I interpreted it as a change in diameter, which is not right. So I'm off by 2 pi, and so it was just supposed to be a slight change in circumference, and I made it much too big. So this one basically slides over the pipe. It's too big.
Yeah, my rule of thumb for 3D printed parts is typically 0.2 millimeters of gap. You start
Yeah.
there and see if it fits.
Yep. Yeah. So I guess that's one of those things. If you don't pay attention, you get to do Ackley's rule of 3. So
Ackley's rule of 3. Okay, I have a question. Not quite robots, but tool related. Does anybody have a sense of the current options for like LiPo system power tools, drills, hammer drills, blowers, things like that? It seems like there's so many out there.
Well, I use
I noticed that I want to get off this 20-year-old Black & Decker NiCad to a modern LiPo brushless system.
Oh, well, that's what I've got as a Black & Decker. I
Oh.
use their battery.
But it's lithium, and it's serving you well, yeah.
these
So-
are nickel metal hydride. So I'm in the Stone Ages as far as
Okay.
tools go.
Ryobi,
Ryobi. 18 volt.
DeWalt.
I don't understand. Did you say you want to get off lithium?
I want to get
No.
off of NiCad onto lithium.
Off of NiCad, yeah. Well, I haven't used a whole lot of these Black & Deckers yet, but they have lithium.
Lithium brushless. Are you pleased with it? Is anybody not pleased with what they've shown?
This thing is probably 15 years old. I can't tell you how many battery packs I've gone through. It's a Timex. It's still ticking, but
So DeWalt gets a +1,
yeah.
My electric lawnmower is a Ryobi.
and those are working for you.
I'm a little bit disappointed with the capacity of the 6 amp hour batteries.
Okay.
You're talking about the actual tools, not the robot.
Yeah, I use a Bosch. Okay.
Bosch?
Yeah, this one's a 12 volt system, and I've had it for a couple of years. Battery's still great. Does, I don't know if I'd want to use it to drill a 1-inch hole through oak, but for normal stuff, it feels good in your hand. And you usually get it with usually when you buy one, you don't just get this, you get the little one that has the that taps while it's going.
Oh, the hammer drill.
Yeah, you get that with it, and I think they're about 120, and they used to sell them for, they always during Christmas and whatnot, they'd sell the pack for $99. So
Yeah.
I know it was, like I say, I really enjoyed it and got a lot of wear out of it. Batteries are long life. I mean, and the batteries, like I charge it up and I use it as I would use a tool. And then sometimes, I might spend a month sitting around, pick it up, just no recharge, just keep going. It's just great.
Oh, that's lithium. See,
Yeah.
this is what. So we got Ryobi, Black & Decker, Bosch, and DeWalt. Nobody has the same thing. It's just
Yeah, my son swears by Milwaukee.
Yeah.
The issue I've had with the Ryobi electric mower is I'll start with what I think is a fully charged 6 amp hour battery. And the way it's supposed to work is when it meets resistance, higher grass, it's supposed to accelerate the motor.
Yeah.
But sometimes I'll start out with a full battery, and after 5 minutes of mowing, just as soon as I hit a little higher grass, instead of speeding up, it starts slowing down and stalling out.